Hello. Uh, never know how to start. How do you start a live stream? Is anyone even there live? Yes, they are. Hi, Urban Maths 2222222. This is going to be another maths live stream. I haven't been live for a couple of weeks. I think literally 2 weeks, or a fortnight, as we say in the UK. Before that word got taken over by the other sort of fortnight. I've got a maths problem. I'm starting the live stream now. There we go. That's our new catchphrase. That's how we start things. I'm starting this. Here we go. Zoe's here too. Hi, Zoe. And Mary is here as well. Brilliant. Here's the plan. I've just got back from yet another summer school. I've lost count a bit. I've been to the whole week for at least 5 summer schools, and I've made appearances at other summer schools. I have collected together some nice problems from various summer schools. Actually, mostly the one I was just on because my memory sucks. Here we are. Zoe is learning Haskell. Is the workbook the one that is learn you a Haskell for great good? What's that called? Is that the name of the thing? There's a famous one. Learn you a Haskell for great good, a beginner's guide. Maybe it's that one. I started, but did not complete Learn you a Haskell for great good. So well done, Zoe, for learning a thing. Everyone else said hi to you. I said hi to Neutrino. Hi, Neutrino. Sorry to miss you out. Here's a collection of problems from summer schools, mostly from the summer school I was just on. This one's about numbers. Oh, actually, Quentin Miller's made their own one. Cool. Presumably less whimsical than the name of Learn You a Haskell for Great Good. Good. So about directed angles. Sometimes I have strong feelings about directed angles. This is the idea that angles can be positive as well as negative. I think everything's a little bit more fiddly, but you're slightly less susceptible to diagram dependencies, I think. But it's the sort of thing people do. I can't think of... right, hang on. So a couple of live streams ago, I decided that I believed quite strongly in the length of a line being a signed quantity, plus or minus. I remember that one because we were learning power of a point or something, and there was a case where the result essentially is that AB times AC. I think these lengths. Hey, what does that say? I've put white text on a white background. I think it says that you've resubscribed. Thank you, Neutrino. 10 months. Wow. Yeah, diagram dependency. There was this thing where I think we decided that this quantity was like, I don't know, some number or something. It was some positive number. Or there was a separate case where they were in this order. And now the same thing is like some... gosh, how did this work? What am I talking about? There were some different cases that you could avoid, and I wanted to pretend they were the same ones. Yeah, it played a noise, which I still haven't worked out why you can hear the noise, because that has no setting for it. So I think possibly you're just hearing it from my room. It's sort of ambient noise. This is what this room always sounds like. People just subscribing constantly. No, thanks, Neutrino. Yeah, thank you. Those were the things we were doing. I imagine there's a similar thing for angles. Can I work out what it is? Probably not. Yeah, probably not. So I'd need to come up with some sort of diagram where... Why am I drawing my points so weird? But hey, some sort of diagram where this case and this case going in different directions matter? What do I know like that? Nothing that I know is like that. Is there that kind of angle side thing where there's a dependency? That's not what we're thinking about though. Anyway, none of this is the question that I've prepared. Not that it's a scripted thing, but yeah. Not that it's a scripted show, but look, I've got a number theory problem on the board. Let's think about the number theory problem. Right. Neutrino subscribers reminded me to shout out to 3 followers. They are third time lucky. Animal Elias, Dr. Cook, and Aperiodic. With the thing that links their usernames is they all have different numbers of underscores in their usernames. Thanks for subscribing. Right, good. Neutrino's got an underscore as well. Huh. Anyway, it's factors. Factors are good. We did factors a little bit before. I can't remember who does everything on stream, but we had a whole stream about like multi-perfect numbers that I think was one of the all-time classics. It involved multiplying lots of numbers together. It's one of the times that I got 196 wrong. Different people in chat discovered different multi-perfect numbers. Great time. What's my favourite maths? I mean, differential equations, especially when applied to fluid dynamics. What are we doing? Whole numbers. There's quite a big disconnect between what I like learning about and studying and using versus what I like talking about. Doing stuff. Yeah. Everyone else in chat, let Rice Cooker Man know your favourite maths. Yeah, that thing about constructing multi-perfect numbers, where we had a kind of trial and error thing where it was trial and a bit of error, and occasionally you would discover a multi-perfect number. Multi-perfect number, for people who weren't there, is one where the sum of the factors is some multiple of the number itself. Perfect numbers are ones where that number is 2. Sum of the factors is twice the number itself. I think I'm including all of the factors in that sum. If you include all the factors, then for a perfect number you get twice the number itself when you add up the factors. But natural question, what if you make it even better by adding up to 3 times or 4 times the number? And there's a way to discover these kind of by trial and error. I don't really know. We don't know much about it because it's all a trial and error process. If anyone's following the F1 on their other monitor, then you'll be amazed to know that Norris has lost it early and Verstappen is now in the lead. Such a surprise. Wow. Right. 3-fict and 4-fict. It didn't catch on. I did forget it. Sorry. Did we find any 4-fict numbers? There's some like surprisingly small number. Maybe not 4, but some surprisingly small quotient or whatever. Abundance? Where we didn't find any, and maybe we don't know any. Yeah. Okay, you're getting some votes now for n-fict. Quite hard to say. Depends on the prefix. Okay, right. Here's the question then. This is supposed to be a bit of a joke question in a way, because come on, 6n is larger than 5n. Larger numbers, more factors, right? And also, if you start thinking about how factors work, you realise that 6 contains within it several factors of its own, which, surely that should mean more factors, because, well, n might have had some factors, and now you also have new ones from this 6. So you get this kind of situation where how could it possibly be that 5n could possibly have more factors than 6n? So you're right there, Zoe. You're doing great. So for this, we need a kind of expression for the number of factors of a number. I'm going to say the word number quite a lot. And a good way to write this is to factorize this out into, I'm going to write it like this. So write your number as, I'm probably not going to bother writing any more stuff. So if you factorize it into primes, then you get different factors depending on what values you pick for the exponents on primes in that factor. A lot of ideas there to do with the factor is going to have its own prime factors. Everything's got prime factors, even the factors of this huge number. And there's sort of a limit to how many of each prime you can put into the factor. For people who've just joined us, Zoe's just learned Haskell, and now everything is a Haskell problem. So the result is that you can make factors like, well, you can have things like 2 to the 0 in there. That's the number 1. What am I saying? You can make choices for what exponents you put on here. So long as the numbers in your factor, the exponents up there, are not larger than the numbers in your starting number. So here I can have 2 to the power of 0 or 1 or 2 or ... or a. So there's sort of lots of choices of how many 2's I can put in my factor. Yeah. Oh, what is that? n plus 1 minus the things that are coprime. Yes, sure, probably. Yeah, sounds true. And what's phi n then? Okay. This one's got a nice expression. I don't know what. This is great. So factors look like this, really. This is a stupid way of showing you this information, right? I should give you an example of like, well, 120 was in chat a second ago. So 120 is 4 times 30, which is 8 times 3 times 5, I think. Yes, 8 times 3 times 5. And its factors all look like things like 2 squared times 3, or 2 times 3 times 5, or 2 to the 0 times 3 to the 1 times 5. You can have a 5 or not. You can't have 25, 2 5s in your factor. And you can have a few 2's if you like. Your factor might be even, it might not be, it might be even, it might be a multiple of 4, it could even be a multiple of 8, because 8 is a factor of 120, but you've got these choices. So you'd have, how many choices have you got then? Well, the total number of choices, you have a plus 1 things that you might write here. A plus 1 because you could write any number from 0 to a. And then separately, and it's totally separate, the number of factors you get, the number of choices you have over here for what to write in this bit. Well, I've written this kind of long, stupid sentence, but really that's just a number. It's a choice from this many things, and so on. Let's just sort of go off the page a little bit. Okay, good. So the number of factors of this sort of thing is a plus 1, b plus 1, c plus 1, d plus 1, e plus 1, ... and so on. So that's the kind of plan of attack here. Multiplying by 5 is going to increase this number, which will give us more factors, of course, because it will make this bracket larger. But multiplying by 6 is going to make both of these numbers larger, so it'll make both of these brackets larger. And that still feels like it should just make the whole expression much larger. And neither of these operations, multiplying by 5 or multiplying by 6, neither of them will affect all of this stuff. So in fact, if n contains some 7s or 11s or whatever, those will still be there when you multiply by 5 or by 6, and they'll give you these brackets d plus 1, e plus 1, and so on. But you know, it's going to be the same in both cases. So it's not going to affect which one's got more factors. Both of them might have a stupendous number of factors because each of them contains, I don't know, something exotic like 13 to the 9 or something. So it's like 10 times as many factors. I didn't finish this calculation down here, did I? I think 120 has got 4 times 2 times 2 factors, which is enormous. 16 different factors. Is this a cute way to lay them out? Let's just do that quickly. Is this a cute way to lay them out? Where you do, so you go in one direction for the 2's, powers of 2, one direction for the 2's, until you get to as many 2's as you're allowed to have. You go in a different direction and you write out multiples of 3, until you get to as many 3's as you're allowed to have, 1 times 3, and then along here you put the sort of products. So along and up, you've gone 3 steps along in the 2's direction and 1 step up in the 3's direction, that gives you 24. Guess what? I would like to Let's do these lines in a different colour. Kind of structure that's going on between these things. I would like a third direction for the 5s. And there's a kind of grid forming here. You can write in a third direction. You can go for the multiples of 5. Take that factor and multiply it by 5. So 8 times 5 is 40, and up here 120. And this is just the right way to do this. I saw this question in a session given by one of the people speaking at the summer school. And the point of his session was you can lay out the factors like this, and it's a sort of nice model of where the factors are. So that's good. Okay, series and factors. And then it's a bit more clear why you sort of have 4 by 2 by 2 as kind of the number of points in this little grid. Yeah, good. Herb's done this for a right angle question. It's a nice way to lay out the factors. Okay, let's go back to the original problem then. We've got this idea about how many factors you've got, and this idea that, well, you can multiply by 5 to increase this bracket, or you can multiply by 6 to increase these brackets. So let's write out, I don't really care about the 7s and 11s, I suppose, because they're going to be present in both. They're going to give me terms like d plus 1 and e plus 1 in both cases. So I think I'm just going to consider, let's go over here and let's do a little bit of maths. This is the sort of thing where you could play along at home, probably faster than me. I don't mean n, I mean k. No, I don't mean k, I mean n. I can't even get it wrong right. Okay. So there's some extra factors from k. We're interested in which is larger. On the one hand, we've got what would happen if we multiply by 6. So coming from 6n, we'll increase the 2's, the number of 2's and the number of 3's. I don't mean 3, I mean v, but this will still be c plus 1. Or thinking about 5n, square brackets or something. Thinking about 5n, don't increase the power on the 2's or the 3's, but do increase the power on the 5's. So a smaller number, and I've only increased one bracket, but maybe this sometimes wins. Okay, plan. I could multiply these out and compare terms. Before I do that, I think I want to simplify the expressions a little bit. I sort of regret this choice. So we've got a, b and c are all greater than or equal to 0. In here I can see lots of plus 1s. So I'm going to go like this. I'm sort of rushing through the question from summer school because I've got a follow-up question that I'd really like to do on the stream. So we're going to try and speedrun our way towards that. Although I say the danger of saying speedrun is that people at home are still going to be faster than me. This is kind of a versus. I'm interested in which is larger. Okay. And now I'm going to multiply out, I think. The trick here is that I took the two expressions and just to make them look simpler, there's loads of plus 1s in here, so I've moved those hide them inside some letters, big A, big B, big C. Quick note to self, these things are now larger than or equal to 1, because the original things were bigger than or equal to 0, I'm adding 1. Good, okay. The reason I'm now happy to multiply out is something like, there's an ABC on both sides, and not too many other terms. So what have I got? Something like a plus b plus 1 times c versus ab. So which is larger? That's going to be our question. On the left is the effect of the kind of 6n. On the right, it's kind of this thinking about 6n. On the right is like thinking about 5n. Just increasing one bracket, just getting one thing. So I think it's clear that if C is enormous, then this left-hand side's huge, right? If I make C big enough. But C might be small. So I'm going to go, what if big C is just 1? Which means our original number had small c equal to 0. It didn't have any 5s in it. If it didn't have any 5s in it, then this term on the right would be AB, and on the left we'd have this. And now actually this thing on the left looks quite small because it's just adding together two numbers, whereas the thing on the right looks quite large. It's multiplying two things. Multiplication is larger, right? So I think I could go something like, what if, to prove that point or something, what if they're like both 3? Because then 7 on the left and 9 on the right. So this would be a case where 5n would win and have more factors. Let's simplify that down. So then A would be 2, B would be 2, and C would be 0. So our original number was 2 squared times 3 squared is 36. And then 5n is multiplied by 5 on Twitch. Welcome to Twitch. We multiply by 5, sometimes with success. 6n would be 216. It's a pretty good number. And then the number of factors is something like, I'm going to factorise them again just to make sure I get this right. 2 squared, 3 squared, 5. 2 cubed, 3 cubed, because it's 6 cubed. So number of factors. In the first case, this smaller number, as 3 times 3 times 2, is 18 factors. And in the other case, 4 times 4, it's only 16 factors. Somebody should do something with that number, right? So even though 216 is enormous compared to 180, and even though it came from multiplying n by something with more factors, that kind of had a lesser effect on the number of factors, number of distinct factors that you get, such that multiplying by just 5 would be a kind of breath of fresh air and give us this extra dimension, so that we go from having 9 factors to having, wow, 18 factors. This sort of effect of introducing a new prime doubles the number of factors that you have in your number. Because, well, if you like, that bit of the brackets that I showed you multiplied together, that bit was sort of 0 plus 1, 5 times 1. Increasing that to 1 times 1 is amazing. And then the sort of diminishing returns. Increasing it from 10 plus 1 to 11 plus 1, who cares? So, this was the question on Mathscamp. More or less, I've changed the numbers to make it a little bit more, well, I've changed the numbers a bit. The plan for this is I would like to know, this might be too hard, but kind of follow up. Do I like the Great Wave? Behind me, the Great Wave. My t-shirt, the Great Wave. The room contains approximately, I'm going to say 20 versions of Great Wave. Yeah, I like the Great Wave. Follow-up question. I've interrupted myself. Easily distracted. Follow-up question is something like, what proportion of all numbers n have that property? Yushuna just got dinner and missed the kind of punchline calculation bit. Rewind, which is good for everyone, I think. We wrote down some expressions for how many factors you'd have when you multiply by 6 or multiply by 5. We compared the expressions and did some simplifying, and then sort of guessed a little bit, guessed some small numbers, and turned out to be fine. But and then we got down to some sort of small value of n, which is the answer to the question. But it feels like along the way I made some guesses, right? I had one bit where I just went, what if C is 1? Another bit where, what if A is 3 and B is 3? Because I just sort of spotted some case where it would be the interesting way around. So, you know. Proportional number of n. So the follow-up question is kind of sort of mad, but I think we can attack it. I think some proportion of all numbers have this property that multiplying by 5 is just better than multiplying by 6 in terms of numbers of factors. That kind of sometimes feels a bit ridiculous because depending on how you think about it, I mean, there's infinitely many, I think there's infinitely many of each. So, what does that mean? But I think I can make statements like 20% of numbers are a multiple of 5 and sort of get away with it. Because, you know, there's infinitely many multiples of 5, there's infinitely many numbers, they're in bijection, something going on there. But on the other hand, 20% of numbers are a multiple of 5. I think we can do stuff like that. Hello, Enstucky. Didn't see you there. Is Chill my first name? Sure, whatever. Yeah. Has Norris got back fast again? I was very rude about Norris a moment ago. It's not some sort of weird pit stop effect, is it? Hang on. For those keeping up. No, yeah, it's done it. Wow. Good lad. Right. Okay, maybe we should be following that instead. Hamilton's up to 9th. That's exciting. Anyone else doing well? Looks at the field. Not really. Anything notable? Anyone want to comment on the commentate Formula 1 with me briefly? No, yeah, that's the only interesting thing that's happening in Formula 1. Sort of sport that you can sort of follow on a second monitor while also running your own stream. Gosh, I hope Liberty Media don't mind me mentioning what's going on in Formula 1. We're just following some other stuff that's going on. Some cars going around in circles. It's great. Okay. So I think we can attack this by thinking about different cases for C. I'm thinking about proportions and whether or not it's true that A plus B plus 1 is bigger than AB. There's some sort of weighting going on here. There's 3 variables, A, B and C. But they've got different weights because, well, half of numbers are even. Most numbers are not a multiple of 5. So the question is mostly about numbers that aren't a multiple of 5 because that's most of them. I'm not sure if it's the case that, well, yeah, most numbers aren't a multiple of 6 either. So let's find out. If A and B are both small, look. So let's think, what have we got? So first, let's think about the C equals 1 case. In this case, this is, am I going to get away with this? This is 80% of numbers. Because most things are not multiples of 5. So we have A plus B plus 1. Ooh. Versus AB. Okay, so I'm imagining this kind of like some sort of chart where can I rearrange this for B? Let's stop writing verses and say that this thing, that the kind of underdog wins. So this is 5n has more factors. That gives me a definite way round for the inequality. I've been sitting on the fence, I suppose, about which way round I'm doing things. So rearranging, I would move the b on the left, divide by a minus 1, and say that I want minus 1, a plus 1 over a minus 1. Thinking carefully, is a greater than or equal to 1? Yes. Good. Yeah. Proportions. Ah, Charlie's here. Hi, Charlie. Missed you come in. There you are. You're doing a break from step, and this is not step. We have new emotes. Oh, that reminds me. We have default animations, but we have animated emotes now. There are two. They look like this. They are in. Oh gosh, where are they? I think they're in the like tier 1 subscriber. But I've also switched on the thing where you can swap channel points for the privilege to use the stupid animated emojis. I don't know. It felt like something else to do with channel points. To unlock an animated version of the emotes you have anyway. But I only did those two. Yes, Neutrino gets it without spending channel points because Neutrino just resubscribed. Everyone gets the one that's on the actual color scheme. If you want to be on the color scheme, follow her. If you don't like the color scheme and you want the one that rotates through all the color schemes, you can, I think, unlock it. I don't really understand, but we're trying it out. Oh, WoW does one as well. There's a WoW one. I forgot that one. There you go. Yes, it was canon. Murray can't use them, but you can. There should be a way to spend channel points to get them. There's like a choose an emote. Yeah, so 480 channel points. I have no idea if that's a lot. It's much less than T. You can choose an emote. Choose an emote to unlock. Oh, you tried that. Okay. Thanks, Twitch. I will look into other things to spend channel points on. Right, anyway, this distracted me from... I've distracted myself from sketching this function. I'm going to rationalize this. Yes, I'm going to sort this out. There we go. It's this, isn't it? It's got an asymptote at a equals 1. That's exciting. That's got 1 plus asymptote at 1 in the long term as well. Those are important numbers for me as well. I guess I know that I'm in that top right quadrant. So what's this going to do? 2 over a minus 1 add a 1. Okay, so it's going to do this. And then I have questions like, is 2... Tell me about these points, right? There's like almost no points are going to be... Oh wait, almost no points are in this region. Maybe? Except for... Right. So... What have we got? Let's label our diagram. We've got this big asymptote and we've got this tends to over here. So all points over here are actually in the case where 6n has more factors. Pause. That does make sense because if you're not a multiple of 2, or if you're not a multiple of 3, which is what these lines mean, big A1, big B being 1, if you're not a multiple of 2 or not a multiple of 3, then adding in 6, or multiplying by 6, introduces a new prime to you, which is, that's what multiplying by 5 brings to the table. Okay, so if you're not a multiple of 2 or not a multiple of 3, then multiplying by 6 up to 6n is brilliant news because you gain a new prime. So, Says I don't have any emotes to unlock. What? I have loads of emotes. I can't do them either. Okay, have I set this up wrong? It's entirely possible that I have set this up incorrectly. And try again later. Twitch. The Chill Maths Miro board sometimes gets cleared out. I used to... quite early on in Miro, I had this bug where if you draw too much, the whole board goes really laggy. So I now try to clear it out quite a lot. What have we actually got in here at the moment? Oh, we've just got like some random step paper and last week's calculations. I had a thought about those. We'll talk about that at some point, but I'm in the middle of this, I suppose. This is quite bad news for my proportion fact because most numbers are in these pink circles, I think. The ones that are left are ones that are multiples of 2 and multiples of 3. They're multiples of 6. That's only 16% of these numbers. Yeah, Charlie's on the brain. Don't think about it. Don't think about the step paper. It's the same one that we went and did before. I'm interested in whether this corn is in or out. What's this then? That's 2. And if I plug in 2, I get 1 plus 2 is 3 for the value of this. So it goes exactly through this point on the boundary. Oh, so that's quite clear then, because then everything else is going to be in the... Everything else is going to be not a tie, because this curve is going to go curve sketching for the win. This is going to explode up to the asymptote over here and can't go through any more integer points. And it's going to decay down to 1 nice and calmly over here, so it can't go through any more integer points. And there's this one on the boundary, which is 2, oh wait, did I say 2,2 or 2,3? 2,3. I need to go up a bit. I love Miro. There we go. It's not quite worked, has it? Because I want it's not quite worked because I wanted to yeah, that'll do. Cool. Oh no, it's going back down again. Ah, you can't scale 1 over x curves. 1 over x curve scales to itself? Yeah, 1 over x scales to itself. Right, good, we've discovered a maths fact. Stop mumbling about maths facts and mark in some more points, James. Right, okay, there's this. Okay, but I'm not done anymore because I've realised it's decaying. It's gone through 3 here. I would like to know whether it also goes through 2 at some point. So there's another kind of boundary point. This is bad news for my fact as well, because there's another case where multiples of what are those? Multiples of 6, but not 12 or 18. That's quite a lot of numbers. Stream where I just mumble. Yeah, okay, question at the moment is related as a follow-up question. The original thing was to find a positive whole number such that 5n has more factors than 6n, which sounds impossible because 6n is larger and 6 has more factors than 5. What's going on there? And then we found one. And it didn't feel that difficult to find one. We sort of guessed some numbers in some inequalities, wrote down some equations, found a solution. After another follow-up question is like, what proportion of all numbers have that property? To start with, we're looking at the case things that are not a multiple of 5, which is most numbers. So it feels like 80% of the numbers are up for grabs here, and it feels like 6n is winning most of these battles. There's a couple of boundary cases here. So 2, 3. Let's think about that number. So this is on the boundary. I'm not trying to remove the default color. I'm trying to use the default color. Come on, Myro. So confusingly, 2, 3 means that I write down 2 to the 1, 3 to the 2, which is 18. So this is a case, I think, where multiplying by 5 and multiplying by 6 give the same number of factors. 60 and 48 is 108, but then I'm gonna factorize them. Yeah, so these go on my YouTube afterwards, which it takes me about a week to put them on the YouTube, maybe 2 weeks sometimes, depending on whether or not I forget. There's some like processing thing there's a processing step that's just long enough that I forget what I was doing. So I have to come back to it to actually publish it, and it's just long enough that I forget what I was doing. Don't think about it for another 2 weeks. What am I doing? I'm doing 2, 1, 3, 2, 5, 1. So the kind of key fact from earlier, just for Charlie, is number of factors, 2 times 3 times 2 factors. You add 1 to each of the exponents and multiply. That's a rule for the number of factors, which is going to be in the what's it called? Video on demand. Nobody calls them that anymore, do they? 3 times 4 really is 12. Good. Okay, they both got 12 factors. 12 factors. It's about factors. Short version. Factors are made of the same sort of primes as your original number. The only rule is that you can't have more of a particular prime in your factor than you do in the original number. So your kind of choices of how many 2s to put in there, how many 3s you want to put in. There's an upper limit, but other than that, it's free for all. So make your choices about how many 2s and how many 3s and how many 5s you want. Here's a little diagram of the factors of 120 on a little cubic lattice kind of thing. 2 direction, 3 direction, 5 direction. Good. Should have picked a larger number for that really to make it more enormous, but 120 was the number in chat, so it was the one we used. Okay, we've discovered that the number 18 is kind of on this boundary. That's fun. Anything else? So I think I need to do it's coming down from 3, it's falling down towards 1. At some point it's going to cross this line b equals 2. And I'd like to know when it does that. Does it happen between here and here, or does it happen a bit later? The kind of battle between pink circles and in a second some sort of other colour of circle over there is going to be important. So let's go. When is 1 plus 2 over a minus 1 equal to 2? So a little bit of rearranging, and I think I want a to be exactly 2. No. That's the number we just had. Rewind. Oh, I shouldn't have tried to rearrange it in my head. Right, okay. Where were you when? 3? 3, because this equation says 1 plus something equals 2. 1 plus something equals 2, and I think it. Yeah, okay, good. I got there. Exciting news. This goes exactly through this point over here. 3, 2. Yeah, 1 plus 1 is 1 plus 1 is 2. But we've moved the emphasis onto the middle word. 1 plus 1 is 2. So, new fact just dropped. 2 squared, 3 to the 1 is another example, I think, which is the number 12. 5n is 60, which is 2 squared, 3 to the 1, 5 to the 1, and 6n is, these are separate, 6n is 72, which is 2 cubed, 3 squared, no 5s, and once again they've both got 12 factors, which is kind of nice. You did not say that 1 plus 1 is 1 in an A-level exam. That did not happen. No. Oh no. That reminds me, since the last 2 weeks, people got A-level results. Congrats on your A-level results, people. Well done. Or equivalent qualifications, I always say, but you know, you did. It was a sequences question. I'm still going to say congrats on your A-levels, assuming that that's all right. 0 plus 8 equals 0. All of these are true if you're working in the right modular arithmetic one. Charlie's one is harder to make true, but not impossible. Fields normally have 2 elements. No. No. Everyone makes mistakes. Part of what we're demonstrating, of course. Trying to do a maths calculation on the board. Everyone makes mistakes. Maybe I'm only demonstrating that I make mistakes. Which is not the same claim, is it? Right, good. Okay, everything else is going to be a win for the other side. That looks like a nice shade of green. What do I want? Are these colours distinguishable enough? There's kind of loads of cases over here. Loads of cases over here where the other colour wins. These are the ones where 5n has more factors. The one we went for before is this one. Other interesting cases, this one. Other interesting cases like this one, we could have picked 4, 2 for an example. 4, 2. That's not how I write 4, 2 because I need to subtract 1. For people who've just joined us, really early on I made the choice that I made the choice that I'd define these capital letters to be one out from some lowercase letters that were a bit more relevant to the question. And I have this original line to write my number very neatly using these lowercase a, b, and c for the powers and the actual number, the thing in the question. And then quite early on, I made this slightly stupid choice to define all of these out by one errors. So I just introduced a whole bunch of mistakes that I could make. Out by one. As I say, happens to all of us. 2 is 1 plus 1. Right. What am I doing? Oh, I've got 24 down here as an example where apparently 96 and 120. 120's got more factors, and it's got loads of factors. We worked that out earlier. It's got something like 16 factors. Whereas 96, oh, rubbish, it's only got 10 factors. 15 factors. From 5 times 3. Yeah, the uppercase and lowercase c's. I tried to do it as a substitution, so I was eliminating the small c's, but I had to move towards the large ones. There's probably a good joke about using 7 c's in here. Can we get towards that? I guess I'd have to suggest there's some sort of pirate question with a lot of integration. I had 7 c's. That's not a good joke. Not a good joke. Hi, up, you're back. You missed an incredible joke. Yeah, that looks likely. We've been sorting out the cases for numbers that aren't already a multiple of 5. Would multiplying by 5 or multiplying by 6 give you more factors? Green cases are where 5n wins. I was going to do that in green. Turns out Myro's not psychic, and I have to actually select the pen. 5n wins, whereas these ones circled in pink are the ones where 6n wins. And of course the green area is huge because it goes off to infinity, whereas this pink area looks really tiny. Though now I say that out loud, we're integrating 1 over x, so area. And is it infinite because it also includes this long line of things down here at 1. Anyway, there's also some weighting that like most numbers don't have so many factors of 2s and 3s. So most numbers lie over here. So I think the way I do this, I could do some really clever kind of summing each column or something, or I could just talk about how, more or less the pink cases are this column, this row, and 1 extra case. So let's do that. Yeah, let's do that. Maths 22222 has got a statement in chat. I think it is the same as mine. I was up here somewhere. And mine involves capital letters. Everything's out by 2 or something. Something like that. Yeah. There was maybe a +1 in there, or maybe not. I can't tell. This is small a plus small b plus 3. Agree. This is small a b. I don't know where your -2 has come from. Probably from this c. Could be the same. Could be the same. Oh, and we've learned that 1 plus 1 is not 2. Or is 2, or something. One or the other. Okay, so that first column is... This first column is all odd numbers. In this case where they're not multiples of 5, but now that I think about it, this is fine. So this is all odd numbers. And then these ones, surprisingly, are most of the even numbers. So then in words, we've got even numbers. Oh no, let's go the other way as well. Let's go the other way. Let's go all odd numbers. Let's do this. Get rid of that rectangle. Let's try and do these ones. We'll double count this, but I'll subtract it, and then I'll add in that one as an extra bonus case of extra even more numbers. So all odd numbers are in this column. All multiples of 3, or all things that are not multiples of 3. Not multiples of 3. I've sometimes tried to call those throd, like threven, for multiples of 3 and throd, but no, it doesn't seem to have caught on at all. So I think I'll stop saying throd. Oh, Herb remembered. Well done, Herb. Problem is, there's two sorts of throd. You can't make statements like throd plus throd is 3, then you have to ask what flavour of throd, and that gets very unpleasant very quickly. Right. So then don't double count odd, not multiples of 3. And also things that are multiples of 6, but not 12, or the other direction is 18. So things lie here if the power of 2 is exactly 1, and the power of 3 is exactly 1, no more. So things that are multiples of 6, but not 12 or 18. Not a step that way and not a step that way, and definitely not both. Okay, I reckon we can count these. Inclusion, exclusion kind of stuff. I reckon we could do that. The first one's just multiples of 6, isn't it? So out of things that are, in terms of what your remainder is when you divide by 6. This pink colour is a bit horrible for writing with. I'm going to switch back to black. So mod 6, you might be one of these. And the first rule says that all odd numbers are a win for, this colour is for 6n winning. All odd numbers are a win for 6n. They don't have any 2s or any 3s. Multiplying by 6 is great news. They get like 4 times as many factors when you do that. Also, things that are not multiples of 3, I shouldn't have 0 and 6 on the board, should I? Things that are not multiples of 3, those are also wins for this. But then in this case, the last thing down here says that some of these as well might also be wins. So out of the ones that are multiples of 6, out of the ones that are multiples of 6, you've got things that are multiples of 6. Do I want to go to mod 36? I'm not sure I do. And I think about how many of the multiples of 6 lie exactly here, that they're not also multiples of 12 or multiples of 18. I think half of them are multiples of 12. Yeah, half of them are not multiples of 12. 2/3 of them are not multiples of a further multiple of 3. So I think it's 1/3 of the cases here. I think. Look back at the diagram quickly. So once you're over here, not on the dashed lines, once you're over here, you're a multiple of 2 and a multiple of 3. And then the question is, out of all of those numbers, which are everything up here is a multiple of 6 now, which makes the multiplying by 6 look less shiny, less new, introducing another 2 and another 3, so marginal diminishing gains to be multiplied by 6 at that point in terms of your number of factors. Whereas being multiplied by 5, ooh, we're still in the case c equals 1 where you don't have any 5s. It feels like even in this case where you're a multiple of 6, I have to remove the ones still a victory for 6n in precisely that case there. So this is something like half and a third. Yeah, it's half and 2/3. Yeah, 1/3 of them move up a row to be also multiple of 3, half of them move that way. It's roughly, yeah, extra dimensions are sometimes better, but it does come down to a kind of numbers game. So if I'm trying to work out how many of these green dots, like how many numbers those represent, I also need to remove these kind of tie cases if I want the 5n thing to actually win. That's going to be tricky. That's going to be tricky. Yeah, maybe come back to that. So this says at most. This is winning. How many of the cases is this then? 5/6 plus in the remaining 1/6 of the time, when you actually are a multiple of 6, if you then don't have any more, which is quite common, any more 2s or 3s, if you don't have any more 2s or 3s, then that's a win for the 6n world. And that's quite a lot. And this is like of the 80% where we're in C=1, still in the C=1 world. This is something like an 18th, 15 18th, 16 18ths is, oh gosh. Numbers, zoom in. 15 18ths, another 18ths. It's getting close to 0% for the greens, isn't it? But it's not quite 0. We had a number. Yeah, maybe I'll work out that one as well, because I want to make a point about these. 15 16 over 18, which is 8/9. Okay. So we've so far checked 8/9 times 4/5 is 32 over 45% of 32 over 45. Which is quite a lot of the numbers. Those are all definitely wins for the 6n. So that's already most of them. Is it going to get down to 0%? We do have the best. We do have the best users. Best viewers already. I don't know why the bots phrase it like that. Oh, can I do that? Is that a thing? That would be good. That would be good. I mean, it would also now have banned you, of course. So get in. If anybody else wants to use that phrase, maybe do it now before. I won't change it live. Okay, so things are not looking good for green. They have got some spots in here, and the spots represent a non-zero proportion of all the numbers. But this is a non-zero proportion. This is non-zero proportion. Can't quite be. You're not a bot. You're a very persistent bot if you are. I can't quite be bothered to work out these fractions. Maybe I should give green a win, right? We should give green a win. So in this column, where we're looking at numbers that are multiples of 2, there's some green wins up here. We could try and work out how many numbers this is. So this is from 4 and upwards. So this is numbers where you are a multiple of 2, and then you're a factor of at least 3 to the 3. So C=1 means not a multiple of 5. A equals 2 means you are a multiple of 2 but not 4. Yeah, even but not 4 even. It's not going to catch on, is it? And then B has to be greater than or equal to enormous 4. So this is things like Freven for 4. Yeah, it's I don't know if that's a setting that I have to enable, that's Joma, or not. I've been live for about an hour. Yeah, this is my normal lifetime. If anybody would like an F1 update, Norris is going strong. Hamilton's in the points. Some other drivers are doing other things. I'm not sure what's notable at the moment. I think they're now at the driving around in circles kind of stage, where they've worked out who's going to win, and they're just unless something happens. It's going to stay in the same order now. Good. We're doing Twitch stuff. Charlie got an email. It's weird to think I have a button for going live. It's weird to think that it also sends emails. Okay. So this is something like 4/5 of the numbers out there pass the c=1 check. And then there's a separate check for, are you exactly a multiple of 2 but not a multiple of 4, which I think is about 1/4 of the numbers out there. Because in the kind of mod 4 world, those would be exactly the ones that are 2 mod 4. So they are a multiple of 2 but not a multiple of 4. And 1 in 4 things are multiples of 2 but not 4. And then having b greater than or equal to 4 means we should subtract the ones where you're not a multiple of 3. B greater than or equal to 4. That means that you are a multiple of... Oh, this is multiples of 27 or something. And more threes the merrier. Multiples of 27 are a little bit hard to come by. I think one thing in every 27 is a multiple of 3. I'm making heavy use of the fact that 2s and 3s and 5s kind of work independently from each other. It's possible that all of this is nonsense and I'll realise afterwards that nothing I've said is true, but hey, here we are. Being up there on the chart, you might be vertically means something like you've got a lot of 3s in your number. So the kind of filter at the bottom is things that are not multiples of 3, and then out of the multiples of 3, a sieving process if you like, things move to the next stage if they are multiples of 3, or even the next one if they are multiples of 9 or 27, and then onwards, and it's all the onwards that win. It's quite a selective club though. Most things are at the bottom where they're not multiples of 3, and then some stuff gets to be multiples of 3, only a tiny stuff gets to the next row and the next one up. So this is some sort of non-zero thing, right? This is 1 part in 135, less than 1% of numbers, but not 0, are green. And actually there's a bunch more to the right as well. So current stakes, we've discovered that the pink 6n wins in really most of the cases, but there's some small cases, like the one we discovered, where multiplying by 5 is a good idea. If you add n, do I know what this means? C squared minus 2 over 2c plus 3. Both the 2's and 3's powers. I don't know what that means, I'm sorry. 135 is quite a weird number, but not that bad, right? Is it even 1 through 5? Can I multiply? Yeah, I think it's 1 through 5. Yeah, I think we're good. That was quite a lazy calculation, right? Because I should just calculate these two and then subtract and get a result for you for all of the green points. This total slice of the world, c=1, adds up to 80%. So instead of messing around with these kind of infinite sums off in this direction, I should just calculate these two. Will I now quietly do that? Maybe, maybe not. I think I want to think about c=2 or larger cases for c, because I think that's going to squash it down a bit. Might become a little bit more tractable. Let's go way up here. Yeah, so this is the thing I want to rearrange for b. I think Charlie in chat, or maths 2, someone in chat. There is an amount that you can add to any number in the pink that will take it into the green. Thus it takes up 0%. Sure, bijections are weird. For each number in the pink region, there is a matching number in the green region. You can probably even do it 1-to-1. These points are not created equal though. They refer to the exponents of 2 and 3 in the original number. So I'm thinking about all numbers n and thinking about, well, like the very first thing we say is like let n be this expression. But if you take some number, I have opinions on whether or not a is. Is it really going to be a multiple of 64? Probably not. So a being large is quite unlikely. The most likely thing is sort of that b is 0. It's not a multiple of 3 at all. C is 0. A, well, even an odd 50-50. So this kind of matching going on where there are tricky things to do with infinity going on here as well. I would like to make claims like 50% of numbers are even. And if you really think about it, that's quite a weird statement because there's infinitely many of each. And you can even do these weird kind of pairings where you try to make it feel like there are way more odd numbers. So here are some collections of numbers. You can bunch them up like this, where actually, because each circle contains 3 things, and there's an even number in there and 2 odd numbers, this is clearly all of the numbers. You can bunch them up like this, and then it starts to feel like maybe 1/3 of the numbers are even. That's clearly not what I mean, right? So these probabilities are a little bit weird on an infinite set. I suppose I mean if you take a large fixed maximum number, there's some probability of anything happening. If you then take the limit of large maximum number going to infinity, then the probabilities tend to some constant. That gets around this problem because if you would look at this, your maximum number is about 15, and then you say, well, where is 14? It should be in this picture as well. So having a kind of, maybe you could think about this as having like a maximum number. That also breaks some of your bijection stuff, where for each number, if your plan was to say for each number in the diagram there's a pink number and a green number, it matches up, or even there's more green numbers over here, well, if you have some sort of maximum ceiling, lots of these numbers are enormous because they've got loads and loads of factors of 2s and 3s. So if you have some sort of ceiling, that could prevent you from doing the obvious matching between the cases. Bijections are weird. Infinite sets are not nice. Let's have another look at that. I'm quite pleased I drew that on the fly. Yeah, good. Happy with that. That's the kind of weirdness that I was trying to talk about that I now have a diagram for. Yeah. So kind of this matching between different points. It's kind of matching between totally different numbers. Okay, I'm going to take a break quickly to get a cup of tea. But I'm going to quickly make a cup of tea. I'm going to roll the kind of adverts that you get. You like to use this moment to also make a cup of tea. No, wait. Mary's going to press a button. Thank you, Mary. Mary says, time to make a cup of tea. No one beat you there. It was weird. There was loads of wind up. No, Charlie tried to. There is a cooldown timer on it to prevent multiple cups of tea from happening simultaneously. Yeah. Oh, 206. There you go. It's a good number, isn't it? I have an idea in mind for the next follower goal, but I'll only say it when we get there. If we get there. Who says this is an increasing function, right? As always, when I say I'm going to take a break, the number of viewers has gone slightly up. So hello to people who've just joined us, just in time for some sort of ad break. I'm sorry if you've just sat through some sort of pre-roll advert, just in time for me to run an advert, but okay. Yeah, when we hit 216, we're building a 6x6x6 cube. That's the plan, because someone in chat pointed out that a 6x6x6 cube has the same surface area as volume. Ooh. So we can build something in Minecraft and cover it in item frames or something. Yeah, so Maths222 is pointing out this fact. Upper left for each number in the sequence. Yeah, it goes into green. If you move in this direction, you always end up in the green region, if you move diagonally. But over here, we're now talking about really exotic, weird numbers that are sort of multiples of 8 and also multiples of 27 or something. So these numbers are really rare on the number line. My diagram is kind of distorted. It includes, going over here, you never see a number that's multiple of 64. Ugh, it almost never happens. Good. What does neutrino links to? Oh, a cool thing. Right, good. Okay. Everyone look at that. I'm going to make that cup of tea. I will see you back in roughly, a couple of minutes or something. There's going to be nothing else on screen because that's how you do these things. Right, back soon. Tea. I'm going live now. Yeah, that was slightly longer than it was supposed to be, wasn't it? People are back. Erbs bought the cars. No ads. Just looking at the screen. There we go. What are we doing? As always, taking a break's nice because you come back and you think, what am I doing? We've got some sort of proportion question. I think we've exhausted all the interesting stuff. There's going to be a problem that, well, we're still in the sequels 1 case. So going to the sequels 2 case, we're going to have an entirely different picture to draw. The inequality is a bit harder, right? Or just more the other way around. Maybe I should be doing this in terms of C anyway. I'm changing A and B. Rearranging. So we've been rearranging this for B, and if I change that, well, let's just put it in decimals. Let's just put it in decimals. What are we doing? Let's just put it in decimals. What do we want? X plus Y plus 1 times, and then the number is called C or something. Yes, I would like a slider. I would like the slider to start at 1 and go to 10 or something. And I'd like that to be less than xy or something. Yeah, that's what I want. I quickly mark in these lines. Okay, so this is the one that we had before, just now, with the point 2,3 on the boundary and the point 3,2 on the boundary, and this kind of special case in here. Let's just tighten this up a little bit. And this region was green. The other region was kind of, oops. There's some text from my clip from my board. Nothing embarrassing, just a message about watching this stream. Top tier professional live streamer. Right, good. Let's now make these black or something. Purple's nice. Good, right, okay, got the colours sorted, that's the important thing. Different cases, but I've realised that if I make C larger, it's going to be painful because there's loads of special cases. There's all these points. And I can't be bothered to calculate with those. Oh, I go through loads of lattice points, that's nice. Loads of examples where they're equal. Here and here and here. And maybe, if we're lucky, over here. Where is this equal to 2? Tell me, tell me, tell me. This is never equal to 2. Am I being an idiot? Does it tend to something different in this case? If x is large, then y is roughly c. Yeah, I'm an idiot. It turns to 2. People did used to send me a link to the old to my own stream. Thanks for reminding everyone of that incredible prank. Let's put it out there. People used to rickroll me a lot more than they try to now. People don't try to rickroll me anywhere near as much as they used to back in the day. Right. Yeah, I'm not sure I'm going to calculate these cases. Probability is not 0? Yeah, I guess try it experimentally, right? The numbers we're talking about are not that large, really. So it feels like checking the cases up to 1,000, you'll get some probabilities. If you replace that with 10,000, I think you'll get about the same probabilities. That might be convincing enough. Probability is not 0. Yeah, we got some examples. We know it's larger than 0.5% or something. We have this case. All of these work. All of these work. And they take up for about 0.5% of all of the numbers out there. Right, we will leave that, I think, for another day because I want to show you another cool maths problem. Works like this. I'm going to type it, I think, because I typed the other one. Consistency. That's what people want. So this is a prove that question. Prove that the fraction m over n with m and n less than 100 does not contain the digits 167 in that order as a block. This is an old BMO question, I think, from the British Maths Olympiad. I don't think it's said in that order, I think it just says as a block. So the idea here is that your fraction, like 13 over 67 or something, does not contain, is not equal to 0. Blah 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 167 blah 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 blah. It doesn't happen, which is kind of quite a wild fact. I could sort of believe doing this question if it said there exists some number, some 3-digit number, such that the fraction m over n doesn't contain 167. Doesn't contain that number. I can imagine doing that question with some sort of like pigeonhole principle or something to say, aha, you have m over n, and ooh, that's not very many possibilities really. How many 3-digit sequences can it really contain? Therefore, I can maybe pigeonhole prove that it doesn't contain some 3-digit number. It never comes up. In fact, I think that's not a working argument because m over, there's like 100 possibilities for m and 100 possibilities for n. That's kind of enough that you might hit all of the 3-digit numbers. So 2 problems there. That proof doesn't exist. Secondly, the number 167 is in this question, just singled out as like that one. Problem. Don't get 167s. No, so fraction, these are whole numbers. Pi, I think, probably does, or whatever. Pi's like normal. How'd you spell? How'd you spell? Yeah, so it's about fractions. It's pretty good. This got added to a question sheet at the summer school I was just on as a kind of roadblock, so that if anybody finished the rest of the question sheet, they would have something tricky to think about to sort of make sure they didn't run out of questions. The fact is that so you're right, it will have a repeating part because it's rational. The repeating part will not contain 167. So I suppose maybe more concretely, how big's that? It's about 13 over 67 is about 1.5, right? A little bit less than 1.5, so it's not going to be 49167. Oops. Oh, I didn't know you could do that. It's not going to be 49167, 49167, or anything like that. Herb just knows lots of pi. The tricky bit for Herb is to count along the list. Work out what number the position is, right? Because you just know pi, you don't memorize the lookup table. Either that or Herb knows a formula. No, never mind. There's a formula for the digits of pi. I shouldn't say that. It's not a useful fact, and it will give you misconceptions about how irrational numbers really work, but there's a formula for the digits of pi. Have you seen it? It's mad. It's this. Discovered in 1995. This is a formula for the base 16 digits of pi. There you go. The sum here is because you then add together all of these things with 1 over 16 and k. So this is useful if you need to know like the millionth digit of pi without working out the previous digits of pi in base 16. Somewhere on this page it says that they've separately found one for base 10. Where is that? Is it on screen now? Another formula. There you go. As a reference. To MathWorld, which is maybe where I should be. But hey. This will give you all sorts of misconceptions about how this is not really how maths works, right? You shouldn't have a nice formula for you shouldn't have a nice formula for stuff. I spend a lot of time trying to convince people that they shouldn't expect a nice formula. Like, somebody comes up to you and says, "Oh, do you think they'll find a formula for the primes?" You say, "Well, not really. Most things don't have formulas." But then it just turns out pi is nice. Pi has loads of great formulas. One of them involves powers of 16 to the k, so that corresponds with the concept of digits in base 16. This is ridiculous. I imagine that it comes from there being lots of formulas for pi and then spotting that one of your formulas contains 1 over 16 to the k. I imagine that's the way you would do it. Or maybe it's better than that. Maybe they're trying to do it. Yeah. What do I mean by a nice formula? Can I prove that there's no nice formula? Yeah. Hands up, you got me, right? This is the line of questioning that, how can I say this? People ask me and then trap me in quite frequently. The kind of idea that there should be a nice formula or that I should prove that there isn't, right? And I'm doing this argument while a really nice formula is on screen. Anyway. How do you derive it? Well, sounds hard. So maybe this is evidence that I should stop being so down on the world. I should stop saying, "Oh, you can't solve these equations. You integrate this nicely. You can't solve this differential equation in a closed form. Sometimes you can. Sometimes you want the digits of pi, and there's a formula for it. So good. Right, okay. If anybody wants to look this up, I'm just going to make it slightly easier for you by copy-pasting the Wikipedia link into chat. Right, good. That's going away. We're doing our 167 fact. Oh, maybe we're just setting the question. Maybe this one I leave for you as a kind of exercise. Yeah, okay, maybe this is something to think about. Yeah, it's handy if you need a precise digit of pi. I mentioned it because Herb was doing the opposite. Herb wanted to find a sequence in pi, which is the opposite question. Good, right, okay. I think that might be my catchphrase, by the way. Good, right, okay. How's Norris doing? Norris is doing very well. Norris has lapped almost the entire field. You've got top 4 teams up in the top 8 places. That's how it normally goes. You've got the rest of the teams in the rest of the places. That's the converse of my first fact. Commentating is hard. I can start to see why they pay people to do it properly. Wow, right, good. Not much to go on that Formula 1 thing. Oh, a question. No, hang on, there's 2 people. Their usernames are the same colour on the screen. This is why I mixed you up before as well, look. And Maths222 has linked me to another formula. We're going down the rabbit hole. Charlie has a question. Charlie, go for it. I think we're not going to solve this 167 thing. It's too brilliant. I would like people to try it. Either I'm going to look at this formula, I'm going to answer your question, or I was going to do some Desmosy stuff. That's a functional equation, Charlie. Nice. Oh no, it's a formula for primes. What have you done? What have you done? Oh no, I've seen this one, it's stupid. I've seen this one, it's really stupid. Yes. Because I've put Wilson's theorem in a talk, and then yeah, the converse of Wilson's theorem. So this is mentioned on the Wikipedia page for Wilson's theorem as a sort of stupid consequence. You have to calculate a factorial. Maybe I should show people this. Yeah, this is really good. It's got all sorts of tricks going on. The cos squared pi, you shouldn't read cos squared pi as, oh, it involves circles and trigonometry. I think the cos squared pi stuff is just there to sort of, you know, map it from some other numbers that come out of this to the numbers that you want, I think. Because, hang on, what did Wilson say? Something like j minus 1 factorial is minus 1 mod j. So sometimes this is an integer. If it's an integer, you'll get, if it's an integer, cos squared of an integer that's half of me, you'll get 1. If not, you'll get something else, and this will get rounded down. So it's a way for detecting integers. It's the cos squared pi thing, because cos squared n pi, the squared is so that the minus 1's go back up again or something. Yeah, cos squared n pi comes back up again. We could put a factor of 2 in there. I don't know why. Anyway, you got to write the number 2 somewhere, I guess. If it's exactly 1, we're good. If it's something else, then round it down to 0. Maths222 changed their username colour to gold? That's worked surprisingly effective. Good question, about the 167 thing. Is this a special case? Are there other ones? There are other ones, I think. I was going to try and map them. Should we try and do that? Let's try and do that. Hints on the 167 thing. So this fact is really good. You can consider, it turns out to be equivalent to does not start with 167. Mumble, if there's a 167 over here, mumble, multiply by 100 to get 1300 over 67, or whatever, 100m over n, really, 100m over n, multiply by 100, now it starts with 167, of course it's got some integer part, but just subtract off some multiple of 67 on top or something, so like minus kn. And now you've got a new example of a number with small m and n that does start 167. So you might as well look there. So you're looking to prove that there's no m over n that starts 167. And starting with 167 tells you something about how large the number is. So there's a hint, if you like, or a different kind of equivalent problem. Proving that it's equivalent, I mumbled some stuff out loud, not very helpfully. So proving it's equivalent is a separate challenge. But if you'd like to start here, then starting with 0.167. There's some interval around there, proving there's no numbers in there. Oh, Charlie asked me a question and then I missed it. Oops. Yes, sorry, Charlie asked me a question. Oh gosh, sorry, Charlie. I forgot you were asking me a question. I got so distracted by Villain's formula. Right, can't do three things at once. Thank you for trying again, Charlie. Yeah, okay, so this thing says this, and it looks like the sort of question I've asked before, so I think I'm going to be okay. You've got this, and you've got a is the integral from 0 to 8 of f with respect to x, and b is the integral from -1 to 3 f of x dx. And you know this fact, that f of x plus 1 is 2, I guess for all x or something. And you would like to find a plus 2b. Right, I think we worked it out. Charlie will tell me if this is not the question. So this looks impossible, right? Because a plus 2b is some combination of these hideous integrals that don't match up. They've got different bits going on. What I've spotted though is that this tells me that f is not periodic, but there's some relationship between what's going on between 0 and 1 and what's going on between 1 and 2, I think. I'm going to try and imagine a function that does this. So then f of x plus 1 is almost the same thing as f of x, but not quite. So I'm going to take this one and rewrite it. So f of x plus 1 is 2 minus f of x. So it says if you put in slightly larger values, then you get 2 minus f of x. Translation magic is going to happen. Quite a lot of it. So stuff between 1 and 2, if you put in numbers between 1 and 2, that's like putting in numbers between 0 and 1 over here, but with a minus sign. That makes me very suspicious that when we integrate, we're going to get a bunch of stuff that cancels. So for example, this thing is equal to, there's some translation magic going on here. I could do a little substitution. So if you integrate f between 1 and 2, then that's the same thing as integrating f of x plus 1 between 0 and 1, because that's going to read all the correct values, I think. As you put in things from 0 to 1, you're putting numbers between 1 and 2 into the actual function, which is what the original instruction was. So I think this is the same. But then this is equal to just the integral of 2 minus f of x from 0 to 1 dx, which is going to be something like, well, this is just 2 integrated from 0 to 1 minus the integral from 0 to 1 of f of x dx. So this tells me something quite exciting, which is, that integration from 1 to 2 gives me 2 minus the thing I would have got from integrating from 0 to 1, and that's going to keep repeating. You can change all these numbers, 2, 1, 1, 0, 1, 0, you can shift everything along by 1. So I think that means that, integration from 0 to 8, say, is going to be integrating from 0 to 1, then 1 to 2, some cancellation there, then 2 to 3, then 3 to 4, some cancellation there. And I think it's going to keep spitting out factors of 2. So I think that the integral from 0 to 8 of f of x might just be 8, and the integral from -1 to 3 of f of x might just be 4. So this might just be the number 16, I think. If f is always 1, then this is 8 plus 4, and another 4 is 16. So splitting it up every 1, I think. So this is like 0 to 2, so f of x dx is just 2. and similar facts are available. Okay, I've got 20 minutes, I think, until about 4 o'clock. Race is finished. Anything good happen at the end? Oh, Norris got fastest lap, I think, just now. Is it still happening? No, I think it's done. Good. I would like to try and do a Desmos thing for the 167. Attempt to prove by Desmos, which is of course not how you do British Maths Olympiad. You don't get computers or calculators. But I reckon I can do a kind of Desmos-y thing. I need like a grid, right? So you've got M and N from 0 to 100. We've done this before a little bit. Because I'd like to take all of these kind of fractions, and just look at the first 3 digits. It's equivalent, it's fine to look at the first 3 digits, which is something like times 1,000. I'll take the floor of that, and that gives you the first 3 digits. So, for example, if this is 1 over 3, then that's going to spit out 333 for the first 3 digits. If it's 2, it gives you 666. If I put in 2/17, it gives me apparently 117 is pretty close to 117 is pretty close to 2 over there, whatever. This is the first 3 digits. I just wanted to look at these numbers, these 3-digit numbers, for kind of all values of M and N. So maybe some sort of, and then kind of plot them, I guess. So plot them like on the axis. 117. Bing. Right. I think this is a case where what I really want is Desmos 1D. You've heard of 3D Desmos. I'd quite like 1D Desmos, I think, for just showing things on a number line nicely. Ah, well, right. Yep, okay. Neutrino's got an idea. Whoa, hello. Neutrinos, what did I press? Oh, I pressed one of my macro keys. That could have done anything. Desmos 3D could do some stuff. Neutrino's got an idea for doing the question. Charlie, maths 2. You switched colours and I forgot which way around you switched colours. Maths 2. Would like to do something in Desmos 3D. You're welcome to do that while I try desperately to. Oh yeah, I see what you mean, because it could be floor of x over y. Not for integers though. I'd like to then look at it and say, there's some gaps. Don't know how to do that for whole numbers only. Okay, I'm going to do some pretty hacky stuff to make M and N separately go from 1 to 100, which is going to look like this. 100, and then I'm going to go some random vector called, I always give my vectors bad names, but you know, something like that. I guess n squared, semicolon, my MATLAB is showing. And then I want to do something like, I want a vector that goes 1 to 100 repeatedly for the numerators looping, and a vector that goes from 1 to 100 quite slowly for the numerators on a slower scale looping. Those are something like m is floor of a over n, and then n is something like a minus n times m, or something mad. The remainder, these 10,000 elements. Why doesn't it like that? Oh, because I have a slider for m and n. There we go. Okay, that looks good. Oh, it's gone over there. Why has it gone over there? These should not be large numbers like that. It's because show me m's and n's. Yeah, they're all over here. Then numbers 1 to 100 in each way around. Look at all those dots. Okay, so my floor thing is not working. First 3 digits shouldn't be more than 1,000, right? No, what am I doing? M over n shouldn't be larger than 1. They shouldn't go larger than 1,000. That's a lot of dots. My computer's not very happy. So why is it putting dots over here? Again, smaller. Analyze problem. Don't show these, there's too many dots. So this shouldn't go larger than... Well, still shouldn't go larger than 1,000. What are these? Why are these here? Who ordered these? How's it done that? I didn't do this very carefully. That's probably what's going on. So you go up to a squared, you go up to n squared. The red points are supposed to be, well, the first 3 digits of the decimal expansion of m over n. So to get the first 3 digits, I'm multiplying by 1,000. I'm doing floor to throw away any more digits that there might be. And then the comma zeros that they appear on the x-axis. And I'm surprised that I thought I was giving this numbers which are all quite small, but it's showing me huge numbers. So I thought I'm just looking at kind of these things. Oh, right, okay, so what's this doing? Oh, m over n, I want m to be... Sure, of course it's giving me large things because it's putting in like 2 over 1 as well as 1 over 2. I would like m to be smaller than n. Can I achieve that? I'll just put m less than n in here, that'd be lovely. I wonder if it's going to pass that. Is it happy with this? Oh, it looks relatively happy. It's no longer showing me 2,000. It was showing me 2,000 before. Yeah, okay. Good, I think I've got away with it. 100 it is. Yeah, good, okay. Dots between this. It wasn't stated in the question, but it's a kind of weird case that 100 over 17 has the same decimal digits after the points as something else over 17, right? It's got some large integer part. Let's go back to the question. Let's put that in the question. There we go. I'm not interested in cases where like this number really is 167 for some reason, or even 16.7. Don't really care. Okay. Good. So what have we got? We've got some missing numbers, including what's this? It's not here. 97 is not in. 167 is not in. 165 is not in either. There are some gaps in this number line, including quite large gaps, like 249 and 248 are missing. Lots of these points appear multiple times. I think I can visualize this with just putting n in here, not 0n, but n in here to visualize how weirder than I thought it would be. Oh my goodness. Putting n in lifts the points up by their denominator. So you can see some patterns in there maybe. Why is it so wobbly? Oh, because I'm doing lots of rounding. So wobbly, like, because I'm rounding these to integers. There's some patterns in there. Some stuff appears multiple times. If you were doing some sort of hideous pigeonhole principle argument, you can now probably argue, oh, interesting. This is 250. And then there's problems getting to 249. Even this only gets to 247. So 249 doesn't appear in any of these. And you can maybe start thinking about these numbers, which kind of almost have 249, and how they're on some sort of curve that's getting close to including 249. That's probably enough. If you tighten that. Oh, we're not trying to do 249, we're trying to do 167. Let's have a look at 167. Where's that? It does not look nice in this picture. Is it this line here? Ah, that's 166. 166 appears. There's a pattern here. 166 appears quite a lot of times. 167 never appears. There's probably something going on there. So some things appear lots of times, some things hardly ever appear. There's 166. There's 167. Just kind of misses. 168 does appear, but only right up there. Let's put that line in. Good, I'm glad I did that, because then it gave me the kind of ability to go to 2 dimensions if I wanted to. Most large primes don't appear. Is that true? Let me try and think of some large primes. Why have I gone over here? I don't know any primes over here. Let's get rid of this. Let's put the 0 back in to squash this back down again. There's quite a big gap, and this is not an error. There's quite a big gap over here where it's quite hard to get things really near. I guess this 1000 would represent things with like a 999, things that are really close to 1. Maybe something to think about there as well. Yeah, chat can work this. Chat can work this out live. 727. Is that another number that's missing? No, 727's in here. Let's put just want a little switch in here. Switch is going to be 1 or 0. Steps in 1. 727 does appear, but only all the way up. All the way up here. That's close. Let's turn the switch off. Back down. Oh, please don't make that. That's great fun. Dip, dop, dop. Brilliant. Lots of things missing around here, around the 666 mark. 666 I reckon appears quite a lot of times. Yeah, so there's lots of different decimals that include 666. That's fractions m over n less than 1 with m and n both less than 100. Here they are. So these are m over n with m and n less than 100 and m less than n. Chat can probably work out why there is nothing over here. So I've got 0. I'm not sure I'm supposed to have 0, but whatever. I've got 0. And then there's a gap. These would represent things like 007 or something. They're all missing. Can you see why there aren't any numbers over here with numerator and denominator at most 100 that begin with 0.007? Gosh, I hope I didn't get sued by any spies at the same time as getting sued by Liberty Media. That'd be really confusing. Formula One's over now. I think that makes me a news kind of outlet reporting on a sporting event after the live broadcast. Norris did get it. Fastest lap and everything. Almost lapped the field, except the top 8 drivers. Great stuff. Well done, Norris. Whew. So these things over here represent quite small fractions, where they're kind of 007 is impossibly small for the start of this decimal. 008 is also impossibly small, and 009. And then this thing suddenly is possible. So you could have a fraction with a fraction that starts 01 anything really. That's allowed. Someone in chat can probably tell me what the switching kind of behaviour is. Why is one of those possible and one of those not? If this question does not start with 0.007, that's a bit easier. Cool, I've set a question for Twitch chat. I don't do this much, right? Where I actually give you a point blank, here's a question. It's a little question, little brain teaser. I don't really know what I do if nobody says anything. I can talk to myself. I have another look at Willen's formula, I think. Good times. So that j minus 1 factorial. Controversially, some people don't count that as closed form because the factorial sign means you've got to multiply those things together. That's kind of more of a recursion kind of thing, where you've got to keep multiplying until you get out to 1. It's kind of a bit strange. So arbitrary number of multiplications, right, for a large enough number inside here. So we want to check a large prime. Write it as an integral. This thing. Maybe. You can probably express all sorts of cool stuff. I've just seen down here all sorts of stuff going on. Oh, right, as an integral. It's kind of even worse, right? Because integration means to go and compute this number from all the values of a function and stuff. Quite complicated construction. It's kind of infinitely much adding, right? In some sense. No, not both of you. And you've used the same phrase as each other. They're not even the best viewers. These people want to give. Why does Twitch make it so hard to ban people? There we go. Good, we did it. I should get points for banning people. Yeah, what are they trying? Amazing. Good. I think we've hit 10 real viewers or something, or maybe that's not 10 real viewers. But maybe there's some threshold where the bots are like, that guy wants to spend money. He's got a taste of it. He's got non-zero viewers, trying to get actual viewers. Urs was telling me, yeah, denominators. It's about the denominator being it's the relationship with the denominator and the number 100. So this one's plausible because that is 1 over 100. So it comes up quite late in my chart, but it is 1 over 100. I don't know why there's so many dots up there. Yes, I do. So it comes up quite late, but yeah, it's 1 over 100. These things are less than 1 over 100, so they don't occur. That's the kind of smallest fraction that you can make using numbers that are less than 100. Integration is only like adding if you consider. Yeah, if your definition of integration involves real and sums, then sure as lots of adding. I'm just being silly, really. I think factorial should count as a basic operation. This makes basic operations more fun. Sort of me moving the goalposts, isn't it? You show me a closed form expression that evaluates to 1 if it's prime and 0 if it's not. In some sense, I know something like that, right? To find out if something's prime, check by dividing it by all of the numbers below, and if it's not a multiple of any of those, then it is prime. And I reckon I can turn that into a formula. I don't think you should accept it as a kind of statement about primes, right? Or any interesting like function to do with primes. But something like that. How would that work? Shouldn't count radicals. Yeah, do I count powers? I think I do. Do I count square roots as being a nice closed form expression? I probably should, because I want to do that fact about quadratics having closed form expressions for their roots. I suppose that's where I should point then, as a branch where, sure, yeah, people have to define radicals quite carefully when they're trying to make statements about the fact that quadratics have neat expressions for their roots and some quintics don't. And we have to be quite careful that you include nth roots for fixed n. Good, right, okay, are we good? We've had a go at this question. I think it's 16, because I think secretly these integrals are quite nice by repeating. We've had a bit of a go at this. We've realised that you can't make some digits in your recurring decimal at the start of your recurring decimal, just because that would be too small a fraction. And there's other ones where 167 is not a particularly small number, but you can't make that either. And there's other things missing as well, like, oh, is that 110? Oh, that's weird. You can make 110. 110. Where's the fraction 110? So it wouldn't have to repeat, but I guess that's 110 divided by 999. But I suppose it could be a little bit larger. It wouldn't have to repeat. It could be 1109, 1109, and that would be a larger number. And maybe that's nicer, or maybe that's nice. Not nice. Not sure. Is there a way of writing the fifth roots of an equation as the value of an integral? So wait, you want an integral where you feed in the number a and it outputs a to the 1/5. That sounds plausible. Yeah. The fifth root's plural? I don't know. Lots of them. Oh, fifth degree polynomial. Short answer, I don't know. What could you do? What could you do? So, something stupid like if you divide by your polynomial, that's got poles whenever you have a root of this polynomial. Maybe you can do something. There's Cauchy's formula, right? But that doesn't tell you where the root is. It doesn't tell you the value of the root. It tells you that it's something to do with the residues at those poles. Mumble mumble. Okay, not an answer to your question, but I think you might enjoy Cauchy's residue theorem. It doesn't answer your question, but I think it's the sort of thing you might like. It's a link between roots of polynomials or functions in general versus something to do with an integral. Not the thing you're asking for, but related true fact. That's the best I can do sometimes. No idea. You've reminded me of a thing. Good. Okay. Where are we going? I wonder if I make these numbers larger. I'm quite surprised that I managed to build these 3 lines. Probably I've done this before. Where am I going with this? Maybe I'm done. Maybe this is it. Okay, one more problem. Which I haven't solved yet, but one of the students gave me. If they're watching, they know who they are. One of the students gave me the following question: is there a power of 7 that starts with the digits 2024? I've written that really weirdly. I should have typed it. Always type the questions. 2024. Hint: do not try calculating powers of 7, hoping that it will happen quickly. Powers of 7 are horrible to calculate, and once you've done 3 or 4, you will lose interest. Is this a UKMT question? A little bit, not really. A student on a UKMT summer school turned up with this question, asked me, and I've thought about it a little bit. I think I've solved it, but I haven't written up my solution, so it's possible that I'm wrong. It's not like copyright UKMT. I guess the previous one was, because it was a BMO question. Oops. But really old BMO question. It's fine. Good. I thought this was a good question in the sense that it's either yes or no. You spend some time thinking about each. Oh yeah, it's 2024. The student who gave it to me likes UKMT questions, I guess. Or wherever they got this from, someone else. Sometimes you just need a large number, right? And you need a large number that communicates large number without people thinking that you mean specifically that large number. I mean, you do, that's the number in the question. But probably this is code for, is there a power of 7 for each 4-digit sequence? Maybe except for stupid ones, whatever that means. But maybe if it's true for 2024, it's probably true for all numbers in some sense. Is there a power of 7 that starts 1, 0, 0, 0? Maybe. If it's true for this number, it's probably true for other numbers as well. And then you pick 2024 because that's the current year. Now I've dated the recording. If you're watching this in the future, try 2025 instead. Oh, hang on. Yes. No one's watching this in 2 years. If you're watching this and you're not sure what year it currently is, then I can't help but maybe do the one on the board first, and then maybe use induction or something until you get to current year. Help, I am trapped in the past and cannot escape. I would come and help you, but I don't have time travel. That's the only sort of time travel I have. The only sort of time travel is for me in 2024 to steadily head towards the time I'm coming, or as fast as I can, towards the time that you're watching this to help you out with the question. But I have to come from the past, so it's going to take me a while. That's the only sort of time travel I can do. Got there. Right, good. Okay, there was the 3 questions from Maths Camp that I wanted to show you. They all involve numbers. Should we try and rewrite this to use the number 2024? That would be fun, wouldn't it? Well, only this one clearly matters what the number is. It's not just arbitrarily true. I guess if we're doing 4 digits, can I just do that? Yeah, here they are. They're a bit more scattered out now, aren't they? 4 digits means that I should... Yeah, and now hopefully I just go over to 2024 and there's nothing there. 2024, nothing there. Brilliant. Okay, great. Follow-up question, same but with 2024. 2024 instead of 167. That felt like quite a risky. Good. Is Chill Maths on next week? Good question. No. Sorry, I have quite a complicated summer. I think we're off next week and back the week afterwards. We've got things to think about. We've got things to think about. We've got the 167 problem. We've got much harder 2024 problem. These are not the same. We've got 2024 problem with powers of 7. I haven't said anything about it. Good luck. And we got some sort of probability. I could maybe finish doing this calculation. I did totally lose interest in it as soon as I went to make a cup of tea. But maybe it's binary. Maybe I make another cup of tea and I get more interested in the question again. How accurately can I determine the percentage of numbers such that multiplying by 5 weirdly gives them more factors than multiplying by 6? And maybe at some point in the future we come back to dogs. I had more thoughts about dogs. The analysis that we were doing 2 weeks ago was both boring and dodgy. I had some ideas. I think we're back. Yeah, work's back at some point. Is there a work stream on Thursday? Murray thinks there might be. Work might be back. Yeah, I'm going back to work. That's it. I'm going back to work. Professional streaming might start again, but then I've got the weekend off or something. I don't know. Chill Maths will return at some point in the future. I hope it's going outside, but won't miss a stream. Crikey. Right, okay. Have a good week, everyone. See some of you for Matt live stream stuff on Thursday. If you're applying for things like Oxford, if you're applying for Oxford for next year, if you applied for Oxford last year and you're now about to start Oxford, I will see you pretty soon in the start of the year. Everyone else, take care as well. Yeah, good. It feels like I'm saying goodbye because I've realised I'm not here next week. Sorry, keep doing that. See you in 2 weeks. Bye. I am ending the live stream now.